Okay, I gave you this sheet at the end of your test, so if you would find it. Okay, so what do you do if you don't know the angle? So for example, a question like a football is kicked at an angle with an initial velocity of 20 meters per second and lands back on the ground 40 meters away. Okay, so we have our VI, it's 20 meters per second. We don't know theta. It goes up, it comes down. Delta dx, they tell us, is 40 meters. Okay, and that's it. That's all we know. So we can break our givens up into x and y. So VIX is going to be VI cos theta, and we know half of it. AX is going to be 0. Delta dx is going to be 40 meters. We don't know delta t. In the y direction, sorry, VIY is going to be VI sine theta. And again, we know the VI, but not the theta. And this is going to be up. Delta AY is going to be 9.81 meters per second squared. This is going to be down. And we don't know the delta T. Okay? So we can start, it's a ground to ground, so we can start where we've always started. We can do AY is equal to VFY minus VIY over delta t, and we can look at just up. So put a u on your t for up, and VFY goes to 0, and we can get delta tu is equal to negative VIY is VI sine theta over AY. The problem is that this time that I can't actually get a number for this because I have two unknowns, a tu and a VI, and a theta. I can double it to get my total time though, so then it will be negative 2 VI sine theta over AY. I still can't find it. I don't know my time. I don't know my theta. Two unknowns, one equation. Isn't it unfortunate that I don't have a second equation? Oh wait, I can go to the x direction. Delta dx is equal to VIX delta t, 1/2 AX delta t squared. This goes to 0. So delta dx is equal to VI cos theta delta t. I can't find things here though because I don't have the theta, I don't have the delta t. But it now just happens to have exactly the same two unknowns as our other equation. So I can now take this and sub it in here. So delta dx is equal to VI cos theta, and you have to change it. You can't leave it as VIX and VIY because you need the cos theta and the sine theta. And then brackets where the delta t is, we're going to write negative 2 VI sine theta over AY. Okay, I don't really like my AY on the bottom, so I'm going to bring it up. And I'm going to take my negative over to this side too before anyone decides they want to subtract something here. Okay, I have a VI, so I brought the negative and the AY over. I have a VI and a VI, so that will be VI squared. And then I'm left with 2 sine theta cos theta. 2 sine theta cos theta. Man, that sounds awfully familiar. Divide both sides by VI squared. Why? Because I want to. So I have AY delta dx over VI squared is equal to 2 sine theta cos theta. So my only unknown now is the thetas. And there's two of them. But they're in like sine theta cos theta. That's kind of weird. I could divide by the 2, but I don't want to. And those of you that recognize this, you would know that I don't want to. There is absolutely no way I can solve this. I have the AY, I have the delta dx, I have the VI. I could put my numbers in, I could divide by 2, I'd be left with some number is equal to sine theta cos theta. But then how do you do the second function sine cos at the same time? You can't. We need to change this so there's just one theta here. So you know those trig identities that I'm hoping everybody has learned in math already? Certainly those of you in the block have. I'm not so certain about those of you not in the block. But there's a double angle identity. And the double angle identity is something like sine A plus B is equal to sine A cos B plus sine B cos A. It's called the double angle identity. And we're just going to make it a little special because we're going to say we're going to let theta equal A equal B. So if we do that, then we have sine theta plus theta is equal to sine theta cos theta. So I'm just subbing in thetas for all the A's and B's plus sine theta cos theta. Well, theta plus theta is sine 2 theta. And sine theta cos theta plus sine theta cos theta is 2 sine theta cos theta. We can use this to get rid of our sine theta cos theta. So where the 2, and that's why I left the 2 here, because I knew it was in the identity. So it now becomes negative AY delta dx over VI squared is equal to sine 2 theta. So when you were learning those trig identities and saying, why do I need to learn these? When am I ever going to use them? The answer is in physics questions to allow us to solve the physics questions. Okay? If you want to check it out, you could pick a number, any number, like 40, and take the sine of it and multiply it by the cos of 40 and multiply it by 2. And now if I do second function sine, I should get 80, because what it's saying is sine of 2 theta. So second function sine, look, I get 80. You got to love it when it happens. All right, so that means I can now solve for my theta. It's only in one spot. So sine 2 theta is going to equal negative 9.81 meters per second squared. Delta dx was 40 meters. And on the bottom, what was it? 20? Yeah, 20 meters per second squared, which is going to be about 400. So sine 2 theta is going to equal 0.981. Okay, all the units are now gone because meters per second squared on the top and the bottom. Now the next question is, do you divide by 2 first or do you do inverse sine first? And the answer is inverse sine, because the 2 theta is inside the sine. So you need to get rid of the sine first. So do second function sine. And when you do, you should get 78.813, okay, degrees. But I want theta. So divide both sides by 2, and you get 39.4066 degrees. Okay? Now, in reality, there's 2 answers for this question. There's 2 answers for this question because there are 2 possibilities where sine theta cos theta would be the same. 30 and 60, right? Because the sine of an angle and the cos of its complement are the same. So the second angle will always be 90 minus the first one, because your calculator will always give you the tinier one. So 50.5934 degrees is the second angle. Okay, so they're the 2 angles. That's and then you take these 2 angles, then I'm going to run out of time here probably. But it says how long was it in the air? So I now take these 2 angles and I can find my 2 times by filling them into my delta t. Usually, unless I specifically ask, usually we only do it with the smaller one. So part B, delta t total is equal to 2 times 20 meters per second. There's a negative there. Sine of 39 off the page, etc., over negative 9.81 meters per second squared. And you will get your delta t total to be, looking for where I did it, I don't know, I can't find it. So what am I doing? 39, taking the sine of that,